All right. So we already learned about ideal mechanical advantage, and this first class lever example, one side you push an effort, so we call that E, and the other side there's a resistance, some sort of weight resisting you trying to push up. If you're strong enough, you push this up, and we call this distance dE, the distance of the effort arm, and then this distance right here, we call this dr, distance of resistance. And the ideal mechanical advantage is nothing more than dE divided by dr. So if this was, let's say this was 10 inches, and this was, let's say, 5 inches, then it would equal 10 inches divided by 5 inches, and that would equal 2. And we would say the ideal mechanical advantage of this machine, assuming you're pushing this side, is 2, which means it should be 2 times easier. Is this 10 pounds? Then I only have to push 5 pounds. Is this 100 pounds? Then I only need to push 50, so on and so forth. That's called ideal mechanical advantage. Today, we're learning something called actual mechanical advantage, and for this we're actually going to have to lift a weight. Now, we're not going to do this with your first class lever yet, your real one that you built. This is just going to be like practice problems. So in actual mechanical advantage. See if I can write a little neater than I did on this side. So actual AMA, actual mechanical advantage. For this one, same thing, we'll put a lever, and let's even build the same lever, right? Let's build the same one. We already know what the actual mechanical advantage is. This side is going to be 10 inches right here, and this side is 5 inches right here. And we know the ideal mechanical advantage is 2. But what is it really? Well, to really know what the mechanical advantage is, we'd actually have to lift a real weight. So you might put like a 10-pound weight here. Let's say, and this could be pounds, this could be ounces, it could be grams, it could be newtons. It doesn't really matter what. So for us, we'll just use pounds for now, or whatever. Okay, so we'll say 10 pounds. And we know that the ideal mechanical advantage is 2, just, because we kind of already cheated and we went advanced. Ideally, it should be 2. And we know that we should push 5 pounds to lift it. But in real life, when you do this, you may end up having to push something greater. So let's say you push 5.35 pounds to balance it. So you're like, I'm lifting. Let's see, I push 4 pounds. Nope, it won't move. I push 4.5 pounds. It doesn't move. I'm not pushing hard enough. I push 5. Oh, it's not moving yet. I got to push a little bit harder, and all of a sudden it starts to lift up. So in real life, what would be the actual mechanical advantage? Well, actual mechanical advantage is quite easy. One side, there's an effort, just like before, right? There's effort and a resistance, and there's a resistance on this side. Whoops. Let me spell that correctly. Resistance. And so the force that this thing's pushing down, this weight, we would call that the force of the resistance right here. And on this side, the side you push down right here, you're pushing downward, we would call that the force of your effort. Pretty simple, just like before. We just add a little E and an R. That's an E there. Force of the effort. So for this, it's FR divided by FE. Now, I know it should be 2, right, in the end, but this one's not going to be, because in real life, it's not perfect, Sometimes there's a little rusty right here. Sometimes it cheats, and actually you push less because this bar on this side is super heavy. And so it's kind of helping you push down. Your plastic one shouldn't be a big issue, but if this was a big bar of steel and you just put a 10-pound weight, man, this bar over here weighs more than this side because it's longer, right? So it helps you. So in real life, everything has got it's more complicated than just measuring each side. So to figure out the actual mechanical advantage, we just need to measure how hard each one pushes. And we go, oh, we put a 10-pound weight on the top right here. And we pushed 5.35 pounds to lift it. So the actual mechanical advantage is this. And then we go to a calculator. And then we go 10 divided by 5.35. Enter. And we get 1.89. Well, 1.87 if we round it, right? 1.87. Yeah, 1.86 with a 9 right here. So I'll just round that to 7. That's good. So there we go. So the mechanical advantage here is 2, but here it's not as good. It's only 1.87. Remember, a mechanical advantage of 1 means there's really no mechanical advantage of all. To lift 10 pounds, you have to push 10 pounds, right? So this one particular one is 1.87. It's not as good as what we ideally thought it was. Ideally, we thought it was going to be 2, but actually it was 1.87. So ideally, we measure distances, and actually we measure forces, and then that gives us the actual mechanical advantage of a machine. And this works for any type of machine, especially any levers for sure. We just take the FR and FE. The force of resistance, how much weight are you trying to move, and how hard did you push to do it? And you just divide them. This pretty much works for almost every single machine. All you're doing is measuring the force you're moving right here and dividing it by the force you had to push to do it, to make it move. And then that gives you the actual mechanical advantage, the real life using it mechanical advantage. So one more sample problem is here. We'll do one last one. It could be even a first class lever, or sorry, let's do a second class lever. So for that, the fulcrum's over here at the end somewhere. And the second class lever, we'll put a weight right here. Let's say this thing is 5 pounds, and it pushes here, and this is the force of the resistance, and it's equal to 5. 5 pounds, 5 newtons. Let's say it's 5 newtons. Let's not go by pounds. 5 newtons, that's an amount of force. And then you have to lift it up over here. This way you have to push up, though, by the way. And the force of the effort to lift this is, let's say it's, I don't know, let's go with 3 newtons, okay? I don't know what the ideal mechanical advantage is, and the reason I don't know the ideal mechanical advantage is I don't know this, okay? But that's okay. I'm not asking for this. I'm only asking right now for the actual mechanical advantage, and for that, all I need to know is what am I lifting and how hard am I doing it to lift it, right? So actual mechanical advantage is equal to the force of the resistance divided by the force of the effort. Now please note that's the opposite of this one. This one has effort on top and resistance on the bottom. Okay, so just note that. And so force of resistance is 5 newtons, and the force of the effort is 3 newtons, and it's pretty much 5 divided by 3. If I clear this out, I get 5 divided by 3 is equal to 1.67 if we round it. And that's the actual mechanical advantage of that machine right there when I used it. Your assignment when you go on is just to do some sample problems is all.